Hi, hello, welcome back to my channel. So today we are going to discuss some important CBSE questions. So as we have completed the reflection part of this chapter, we will focus more on the questions. So let's begin with the first question. Yes. So first question says, when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. The image is. So here we have two clues. It says within the focus of a concave mirror and enlarged image is formed behind the mirror. So we have already learned the image formation by concave mirror, and we know that at one position we get the image behind the mirror. So what is that position? Yes, between F and P. This is the only position where we get the image behind the mirror. So what is the nature of the image in that case? Virtual and erect. Very good. So option is D. Now let's move on. Second question, the laws of reflection hold true for plane mirror only, concave mirror only, convex mirror only, all reflecting surface. So laws of reflection is applicable to all reflecting surface. Not only mirrors, lenses, it is applicable to all reflecting surfaces. Now third question, the image of an object placed in front of a concave mirror of focal length 15 cm is of the same size as the object. The distance between the object and the image is. So here we have to find what is the distance between the image and object. Now let's see, it is a concave mirror. Focal length of the mirror is given, and also it says that the image size is same as that of the object. At which position you are getting same size? Very good, at C. So when the object is placed at C, you will get the image at C itself. Then only you will get same size. Now we have to find what is the distance between object and image. Okay, not the object distance, not the image distance. We have to find the distance between object and image. To read question very carefully. They are asking for object and image. So let's see, we have concave mirror. Okay, pole of the mirror, then focus of the mirror and center of the curvature. It says focal length is 15 cm, and we also identified you'll get same size image when it is placed at C. So what is the distance from the pole of the mirror? This is already 15, so this distance will be 30 cm. Why 30 cm? Because we have the relation R equal to 2 times F. So if focal length is 15, R equal to 2 into 15, that is 30 cm. So radius of curvature means it is from the center to the pole. So you will get, your object is placed here and you will get the image here, same size image here. Now what is the distance between object and image? Yes, there is no distance. So no distance means 0. If the question is what is the object distance, then object distance is measured from the pole to the object. So what is the object distance? 30 cm. If the question is what is the image distance, again image is also formed at C, and from the pole to C, that is image distance, that is again 30 cm. But here the question is little tricky. It is asked for the distance between object and image. So object and image, since both of them are formed at C, there is no distance between them. So option is D, 0 cm. Now next question is, in which of the following is a concave mirror used? So a solar cooker, a rear view mirror, a safety mirror in shopping malls in viewing full size image of a distant object. So here option A, we use concave mirror for solar cooker. What about a rear view mirror in vehicles? It is a convex mirror. Why we use convex mirror for rear view? because it forms virtual, erect and diminished image, and also it can cover wide area. Now safety mirrors in shopping malls, again convex mirror in viewing full size image of a distant object. So for distant object we use both concave mirror and convex mirror, that is position of the object is at infinity. So when the object is placed at infinity, you get the image at focus and the image formed is highly diminished. So this can be formed by both the mirrors, concave as well as convex. But in order to see the full size image of the object, we cannot use a concave mirror. We cannot use a concave mirror to see full size. Even though concave mirror forms a highly diminished and it is formed at focus, it will not give you the full size image of the object which is very far because of its shape. But what about convex mirror? We can use convex mirror in this case. We can use convex mirror in this case because convex mirror can form virtual, erect as well as highly diminished images. Okay, convex can also form highly diminished, but the speciality of convex is that it can cover a wide range so that you will get full size. So here the option is A. In all these cases we use convex mirror. Now question number 5. For the diagram shown, according to the new Cartesian sign convention, the magnification of the image formed will have the following specifications. So a diagram is given here. So let's analyze the diagram. So it is a concave mirror. So the mirror is a concave mirror. And where is the object placed? It is placed between F and P. So what are the specialities of the image formed between object placed between F and P? Yes, image will be formed behind the mirror. You will get behind the mirror, and it is enlarged or magnified, and also it is virtual and erect. So what is the sign of magnification if the image formed is virtual and erect? So magnification sign is positive if it is virtual and erect, if the image formed is virtual and erect. So you can cancel out the options. So C and D you can cancel out because it says that the sign is negative. So we can cancel it out. So here we have identified it is virtual and erect. So magnification sign is plus. Now we have to identify whether it is less than 1 or more than 1. So magnification values. What does the magnification values indicate? Values indicate whether the image formed is enlarged or diminished. So if magnification is greater than 1, then the image formed is enlarged. If magnification is less than 1, then image formed is diminished. And if it is equal to 1, then it is same size. So here it says that the image formed is enlarged. Okay, from the diagram we have identified the image is enlarged. Image is enlarged means magnification is greater than 1. So what is the right option here? Option B. Option B is the right option. So there are a lot of things you have to recall when you solve an MCQ. So be thorough with all the ray diagrams and the sign conventions before you solve the questions. Now let's move on to the 6th question. Okay, so 6th question says the radius of curvature of a concave mirror is 30 centimeter. At what distance from the mirror should an object be placed so as to obtain a virtual image? Okay, so here radius of curvature of a converging mirror. So which mirror is converging? Very good, concave mirror. Concave mirror is a converging mirror, and they have given radius of curvature. Radius of curvature is 30 centimeter, and if you apply sign convention it will be minus, because for a concave mirror which side you will get radius of curvature? Yes, left side, this side. Left side you will get the radius of curvature. Now, at what distance from the mirror should an object be placed so it obtain a virtual image? So we know that for a concave mirror, you will get a virtual image only at one position. What is that? Yes, but you will get between F and P. This is the only position where you will get virtual and erect image. Now you have to identify the object distance. Now let's see, we have radius of curvature given and we have the relation r equal to 2 times f. So here r is minus 30, then which is equal to 2f. Therefore f is equal to minus 30 by 2, that is minus 15 centimeter. So your focal length is 15 centimeter. Minus indicate it is on the left side. Now to get the virtual image, where should you place the object? It should be placed between these two. That means from pole means it is 0, origin 0 centimeter. Pole is the origin of the mirror, so it is taken at 0 centimeter. So from 0 centimeter to 15 centimeter. So between these range 0 to 15 centimeter, between these values you can place the object. You can place here or here or here or here. So that is the range. Okay, this is the range. So what is the answer? Between 0 and 15. So option D. Now next question, 7th one. Which of the following statements is not true? Okay, not true in reference to the diagram shown below. So here again it is a concave mirror. Object is placed at C. So what are the, it is talking about the image characteristics here in the options. So what are the characteristics of the image formed when object is placed at C? Yes, real and inverted. First is real and inverted. Then size will be same size. And image is formed at C itself. So these are the characteristics of the image formed by this object. Now let's see which option is correct. No, we have to find which is not true. So image formed is real, that is true. Now image formed is enlarged, that is false. This is true, this is false. Image formed at a distance equal to double the focal length. Yeah, that is true, because at C means it is double the focal length, because the relation is r equal to 2f. So this is also true. Now image formed is inverted. Yes, here we are getting inverted. So it is also true. But as per the question, we have to find not true. So which is not true? Option B. So the right answer is option B. Next question. An object of height 4 cm is kept at a distance of 30 cm from the pole of a diverging mirror. If the focal length of the mirror is 10 cm, height of the image formed is. So we have to find height of the image. Now here it says diverging mirror. So which mirror is diverging? Convex. So it is talking about convex mirror. So it is a numerical problem. We have to find height of the image. So let's write what are the terms given. So height of the object is given. So HO is given as 4 cm. Don't forget to apply sign convention. So object is always placed above the principal axis. So the sign is plus. Now object distance is 30 cm. That is U is equal to minus 30, because object distance is always minus because it is placed at the left side of the mirror. Now focal length of the mirror is given 10. So focal length F is equal to plus 10 centimeter, because for a diverging mirror focal length is formed behind the mirror. It forms virtual, so behind. Now you have to find HI. So to find HI, we should know what is V, because we have the formula HI by HO is equal to minus V by U. We have HO, U, but we don't have HI and V. So to find HI, we should know V. So let's find V first. So you can use mirror formula. 1 by F is equal to 1 by V plus 1 by U So f is 10 centimeter. So 1 by 10, which is equal to v, we have to find. Then plus u is minus 30. So minus 1 by 30. Now we have to see the sign. So here plus and minus. So plus minus becomes minus. So 1 by 10 is equal to 1 by v minus 1 by 30. So we have to find 1 by v. So take minus 1 by 30 to the other side. So let's take 1 by 30 minus 1 by 30. When it comes to this side, it becomes plus 1 by 30, which is equal to 1 by v. Now let's find what is v. So we can take LCM as 30. So here you will get into 3, you have to multiply by 3 at the numerator and denominator. So 3 plus here 1, which is equal to 1 by v. So you'll get 4 by 30, which is 1 by v. We have to find v. Therefore v equal to, just take the reciprocal of this. So 30 by 4. 1 by v is 4 by 30. So v equal to 30 by 4 centimeter. So what is 30 divided by 4? Yeah, let's do 30 by 4. So 7, 28. So 2, 0.5. So you will get 7.5. So 7.5 centimeter. Now apply this formula and find HI. So HI by HO is equal to minus V by U. So I am substituting. So HI by HO is 4 equal to 1 minus is already there. So put it outside the bracket. Now V. Instead of substituting the decimal value, it's always better to substitute the fraction value for easy calculation. So I am substituting 30 by 4. Now u is also there into u. U, what is u value? Minus 30. So minus 30. Now close the bracket. So you can cancel out 30 and 30. This minus and minus becomes plus. So you will get 1 by 4. So HI by 4 is equal to 1 by 4, or HI is equal to 4 by 4. Just take this to this side, which is equal to 1 centimeter. So what is the option? Option B, 1 centimeter. That's it for today. So don't forget to revise the formulas, sign conventions and ray diagrams thoroughly before you start solving these questions. So we will meet again with another set of questions in our next module. Till then, bye, thank you and take care.